everyone. I'm David Daniels, Partner Solutions Architect at AWS. Welcome to Howdy Partner. Howdy Partner is our weekly show where we introduce you to partners that are doing some cool stuff and showing some cool solutions and want to show it off to you, where we get to talk to them and meet them and learn all sorts of cool stuff. With me today is Prachi. Prachi, go ahead and introduce yourself.
So, hello everyone, I am Prachi Doshi and I'm a Partner Solutions Architect here at AWS as well, along with David. So, excited to be here on the show. This is my first time on the show. So, yeah, looking forward to it. And I'm joining in from Seattle today. Not so sunny today, but yeah, as long as it's not raining, we're all happy here.
Yeah, absolutely. I'm coming from Denver today. So, we've had an interesting day. We have an infestation of moths. It's actually moth season out here right now, so that's made it a lot of fun. Today we had rain and hail and a thunderstorm and moths. So I'm curious to see what happens next. Yeah, it's great to have you, Prachi. Welcome to the show. Do you know anything about who we have today, who we're talking to?
Yeah, we have a partner Jij here today, and they are specialized in quantum computing. So I personally do not have a lot of idea in quantum computing, so really looking forward to hear all about it. So
yeah, I don't have much experience with quantum either, but this show we've actually been really interested in quantum lately. We've had a few shows about it, and we have someone for that. So once again, we've brought in our resident quantum expert. You may have seen him before. Going to welcome Parminder to the show. How you doing, Parminder?
Hey.
Welcome.
How are you, Daniel and Prachi? Yep. I think I will introduce myself. I'm Parminder Singh, based out of Dallas, Texas, and I take care of our partner in a quantum space. So what I do with them is we involve with these partners, and I have few of them, like I lost the count now. I have the partners from all over the world now. So me and my business, the PDM, Safan, Yang, and Tejas, they help me from the business side, but I take care of the technical matter. And we work with this partner to build the solution on AWS Cloud with our Amazon quantum service called Bracket, right? And when we work with this partner, we also work on go-to-market activity once the product is built, right? And then we, of course, we are doing this for customer, and we do joint co-selling motion. So one of such partner is JijZept. They are based out of Tokyo, Japan, founded in November 2018. And they have this software or solution called JijZept. So it falls under quantum computing, and under quantum computing, sort of like optimization. And I think more on that from JijZept. So why don't we invite them?
Yeah, that's awesome. Sounds exciting. So we'll go ahead and bring JijZept on. We have got you and Hiro joining us, and welcome.
Hey.
Where are you guys joining us from?
Okay. So I'm Yamashiro, so from JijZept. I'm a co-founder and also the CEO of JijZept. So my background is more fundamental physics. However, currently I'm spent time for some of the work for the CEO staffs. And nice to see you guys.
Welcome. Nice to have you here. How about you, Hiro?
Hi. So yeah, my name is Hiro, Hiro Nakata from Tokyo. So I'm staying in Tokyo now. So I'm the head of business in the JijZept. So I'm covering the expanded business in Japan, Asia, and Europe and the US. Glad to see you.
And you were telling me, what is it, 6 a.m. where you're at?
Yes, it's a 6 a.m. So I wake up at 4 a.m. When you wake up, you may be like
and also the same time.
a bit, yeah, like.
Oh, we appreciate you waking up early and joining us to talk about this.
Yeah.
So
thanks for your arrangement. Yeah.
Yeah. So why don't we start with some history about the JIJ, the company, and the roots?
Okay, so you could you start the your presentation?
Yeah.
Okay.
Go ahead and add it.
Okay. Thanks. Yeah. Okay. So yeah. First, we believe to begin, briefly introduced about our company JIJ. So, but by the way, so JIJ, so that is just a character. So, because that means that so we are the physicists. So, and also my main major is statistical physics, and the statistical physics we use in the Ising model. So that is a very fundamental model for the some magnetization. So in the Ising model, we are always using the character like capital J and also the small ij for the representing the connection between the each atoms or the each some spins. So well, we uh, take the character as a company name. So that company name so shows that we are the some statistical physicist team.
I'm sorry, we got a question in the chat just about the pronunciation. Is it JIJ? That's how I've been saying it. Is that correct?
Yeah. J, I just read each alphabet.
Okay.
Yeah, thank you. So yeah. So and I introduced our team. So me and CTOs Nishimura from the Tokyo Tech and also the Nishimori Labo. So in the Nishimori, he's the first investor for the quantum annealing. That is a very well-known quantum optimization algorithm. So for example, if you know that some quantum hardware company called D-Wave, so they are the first quantum computing company. So however, their hardware based on the Nishimori's theorem. So we are the mainly study about the quantum optimization algorithm. And also we provide the quantum software, quantum middleware services. So after that, I introduced more detail. So before the technical parts, I also showed our business. So our business have a two part. So one part is the JijZept. So also the Zept, that name take from the physics. So in the statistical physicist, we also use the alphabet Z for that is a partition function. So a little bit it's a complicated function. However, so you just know that statistical physics always thinking about these capital Z. So and also the Zept mean that so that means that very tiny or the very fast. So we use our software called JijZept. So and also Zept provide some middleware features for the connection, the optimization problem, and also the quantum or the conventional hardwares. And after in this session, I'm also more introduce the technical part. And also the right side show that our consulting and joint R&D services. So we also have a lot of use case with our customer through our platform. For example, the Toho Gas is a Japanese gas company. So we collaborate with Toho Gas for the control of the energy supply problem. And also we have a project with the Toyota Tsushin for the optimization of traffic light control. So yeah, Okay, firstly, so I briefly introduction of the JijZept. So in JijZept, connect the mathematical modeling and also the hardware. That means that so if you want to solve the mathematical optimization problem in the quantum or the another quantum inspired problem, you have to convert from the original problem to the intermediate representation that is quantum hardware can understand structures. For example, we say sometimes the Kubo, or we say sometimes the quantum circuit. So, but Zept can automatically convert to these intermediate representation from the user-defined constraint optimization problem. And also the Zept submit to after the solved on the quantum or the conventional solvers, Zept also execute the post process for the noise reductions and also for the more improve the solution from the quantum or the another conventional solvers. And also we Zept provide the problem decomposition functions. That is the most key point of our technologies. So currently, in the world, so quantum startup, a lot of quantum startups established for the software connecting the real world problem and the quantum devices. However, the most software just connects the problem and the hardware. However, in current state, quantum status is quantum device is very small, or the quantum device or the quantum inspired problem currently just now is a growing era. So we have to collaborate with the conventional computer and quantum devices. So our product provides the automatically decomposition features and also the automatically hardware correlation features between the quantum and the conventional computers. And after this introduction, I'll a little bit more. I want to explain a little more detail of these topics.
Yeah.
And also our Zept has more good features for the cloud large-scale optimization problem. For example, our product can 5 times faster executing the pre-processing, and also our data structure can compress the data size. And also we have our use cases. So some use cases are already published on the website or the news site. You can check that. For example, these traffic signal optimization algorithm you can check from the Microsoft blog and also the Wall Street Journal. So if you if you're interested, please check that. And also we have an open source project called OpenJIJ. So that is a very fast Monte Carlo calculation tool. You can now you can try by the pip install. So if you want to try the optimization algorithm by the quantum or the quantum inspired technology, so please try it. Okay, that's all from about introduction of our companies. Thank you.
All right, cool. Thank you, Yu. So definitely try that OpenJIJ. I'm going to throw a link in the chat, and you'll see it on the ticker on the bottom of your screen as well.
Yeah. And I think there are some technical terms here, the cubo. So that are like a, quadratic unconstrained binary optimization, full form for that. And there are like typically we call some of those problem as optimization problem, right? And then those who are familiar with the complexity theory, this all fun are under NP hard problems, right? Very hard to mathematically solve on using classical compute resources, right? That is where the quantum play a role into. But then optimization problems can range from things like graph coloring, max cut, partition problem, number problem, and then the use cases apart from what you show, like think of like a scheduling problem at a hospital for the nurses or the doctors, or even like flight schedules, right? So anything which has to do with logistic optimization, they all are bundled under optimization as a problem, right? And then there are traditional way to solve that on classical side, but I think what JijZept software is doing in a very novel quantum way, to put it in a nutshell. I think let's see this in action.
I actually had a question here. So I read in one of the slides that you mentioned that instead of building a complete quantum solution, you try to put it on the most effective part and try to solve that. So could you elaborate a bit more on that? On like what does that actually mean? Like how do you select those parts, and what do you mean by just applying it to the most effective part?
So master effect. Sorry. But you're talking about that. So how to choose. So in there, so there's we have a lot of the kind of the mathematical optimization problem. However, for example, this mathematical optimization problem can separate two groups. That the one group is that is written by only the continuous variable. For example, the storage of the so for example, in the energy sections, the continuous variable represents some storage of the oil tank, and also that another group that is written by the discrete variable or the binary variables. For example, the representing the root or representing the which we should choices. So this is a very different problems. In a continuous variable optimization problems can solved in the conventional computers or the conventional algorithms. However, in the discrete variable generally, so that called the NP hard problems. That is a very difficult to solve the problem. So we expect that these problems can handle quantum or the quantum inspired algorithm better than the conventional workflow. So if you want to use the quantum technologies for the realistic problem, and also that if you want to get the advantage or the better solution for more than the conventional workflow, you have to firstly you have to find the discrete variable problem. Because if you of course we can solve the continuous variable problem in the quantum devices. However, we doing that, so we could not advantage from the quantum technologies. So if you want to do that, I want to say just that you have to choose the correct technology for the correct problem.
Got it. Okay. Yeah, that makes sense.
So, you or Hiro or Parminder, any of you that can speak to it, I guess, I'm curious as to what kind of, so a lot of us are kind of seeing a lot of this and not really knowing or understanding what it all means. What kind of, I guess, what are some examples of some of the real world problems that you're using to solve or that you're solving with all of this right now? I'm kind of curious. Maybe some others, some of the viewers want to know what you can do.
Okay, so wait. Let me show firstly our product documents side and also some realistic example.
Yeah, as you are bringing that website, right? If I can think of an example, now I didn't say in my intro, I'm still studying my master's in quantum computing at our University of Madrid. So, but one of the problem which we solved during one of the course was like this nurse scheduling problem which I was talking, right? So think of a era of COVID when there was like a lot of burden on the hospitals or resources, and how do you schedule the nurses shift in the hospital? And then you think of a work week, then you add some constraint like nurse one can only work with nurse three, and then the load of one nurse is not same. So they're like a soft and hard constraint, right? And then you have to set up a function, and that function objective is called an objective function in this scheme of things in optimization side. So basically what you are trying to do is like come up with the most optimized schedule for all the nurses to operate in that work week in that hospital, right? It is a very hard problem. Now you can think of another set of the problem. I was saying like the flight scheduling. Think of like in the US region alone, the airlines, and then how do you schedule with an American if you pick any airline, right? Like when the flight has to come and go, and then creating the roster for the captains to have most effective flight schedule, right? There are a lot of various component behind the scene, right? Me and you just feel like, oh, it's just like a few clicks here and there, and then schedule will be published. But there is a mathematics behind it. That is what, in a nutshell, is called as like a unconstrained binary quadratic programming. So the math behind it, this whole quadratic side, and then what you are trying to do there is like, if you use the traditional source resources, because of this NP-hard problem, you will be solving this in exponential time, right? And your task is like, how do you bring that exponential time down to a polynomial time? Now I'm using those words, polynomial, exponential, a little bit mathematics around that, but the people who are in this industry will understand what I'm talking when I talk about this exponential time it takes to resolve or solve this kind of a problem. But the real world problem, what you is showing, this is more around mathematics. So let's hear from you.
Okay. Thank you for the introduction of the more realistic problem. So yeah, so we also I say that we also have a realistic applications. However, so before talking about that, so I a little bit introduced about the more little bit fundamental, but the closed applications example. So for example, that is a job schedule problem. So that is if you have some you have to align the job scheduling. So for example, left side is the tasks, and also the lengths represent the times handle the tasks, and the right side is some computer or some machines, so they can handle the left side tasks. So that is how to reschedule each task to these machines. That is a very well known job scheduling problem. So and also that so these fundamental small example can apply to the more a lot of realistic problem. So that is a job scheduling type problem. And also that if you are the biologist, so we can apply to the protein folding problem. So that a little bit, but that is a little bit how to say that all the research project in the 20 that is the investment out there 2012. However, so these problems, well-known difficult problem. Also, this protein folding also can handle on the using and Kubo optimization technologies. And also, if you are the financial person, so also the portfolio optimization is a part of the mathematical optimization problem. So portfolio optimization means how to choose a stock for to improve your revenue and also decrease your cost. So that is also the very well-known optimization problem. So optimization problem very existing in the very widely. So if you maybe you can find the optimization problem in your industries, and also that I also will a little bit explain about our kind of project. For example, the traffic signal optimization that is the aim to create the smart city. So that so Toyota and also a lot of vehicle company aim to reduce the emission of the carbon, and also they aim to the more sustainable environment. However, so for these teamers, so they research and develop the engine of the vehicle. For example, that they try to convert to the electric vehicle. However, so if we can control the traffic signal optimally, so we can reduce the carbon emission through all the cities. So that is a very big thing. So we do not even we do not provide a new car. If we can just control a traffic signal, we can reduce the carbon emissions for the city. So this is a very big problem for us. So currently we are researching about these tamers. And also the next is KDDI is the Japanese biggest telecommunication company. So we are we execute out of project related to telecommunication problems. For example, the optimization related to some telecommunication base station. That means how to so where we set the telecommunication base station, and also how to set up the angle of the telecommunication base, and also the Toho gas project that's called cogeneration system. So so currently we have a lot of energy supply resource. For example, so we can take from the energy from the solar, and also we can take from the another supplements. So in the Toho gas project, we aligned and adjust which we adjust the scheduling the energy supplement problem. And also another thing, we also executing the robust structure optimization problem that is related to the material information technologies. And also another thing is currently we are focus on the more energy sectors problem. In the energy industries, a lot of the optimization problem. So, for example, the EV and also the oil transport. So, currently we are focused on the energy sector. However, I also say that so optimization problem exists in the widely industry. So maybe you can find your industries. So that is a very brief introduction of our use cases and also the fundamental realistic problem of the optimization.
Awesome. Thank you, you. And one of the things that jumped out was you're talking about smart city, and we do have an AWS smart city competency. Do you have? I guess I'll ask, what has your AWS partner journey been like so far? Like, any benefits that you've obtained that you can speak to, or anything that you can say about being an AWS partner up to this point that you've really liked or benefited from?
Mm-hmm. Okay, so first, yes, I will say about our expectation for the AWS partnership about that thing. So, there's of course, the AWS have a lot of infrastructure for the world. So, smart city that cannot executing only the one technology, for example, the traffic signal optimization. So if we create a smart city, we have to collaborate the technology and also the infrastructure. So we expect that. So we have a optimization technology, but that's it. So we have to create a infrastructure. So and also we have to build on the infrastructure. So we expect that AWS. So we use that AWS infrastructure for the smart city, and also the after that, so we want to implement on this infrastructure our technologies. So we want to more discuss or improve the discussion for the smart cities connect to our technologies.
Awesome. Thank you.
Great. So we can see your website, and if you can show some formulation of the optimization. Was that a plan today? I don't want to put you guys on spot.
Okay. Right. So so also you can see that our website, JijZept website. So you can see the more detail of our product and also how to mathematical optimization problem. Firstly, I'm also talking about how to create the application. So after this, I want to also talking about the more technical part, so related to the AWS technology and our JijZept. It's okay. So
yeah.
Well, I also say about talking about OpenJJ. That is an open source project. So this open source project provide the algorithm for the simulated annealing and also simulated quantum annealings. So these three algorithms are a similar name. However, a very different algorithm. So simulated annealing is a very well known conventional computing algorithm. So in the physicist, the conventional computing technology called the classical computing. Classical means it's not the old, just say that is not the quantum. So don't confusing that. So simulated annealing is a classical algorithm, and also the simulated quantum annealing is also the run on the classical optimization classical computer. However, that is a simulation of the quantum version of the simulated annealing. So that is a very very different algorithm. So however, the simulated annealing is a very good algorithm. However, the simulated quantum annealing that is just simulate the that is just simulate the quantum phenomenon. So if we ignore the simulation cost of the simulated quantum annealing can outperform the simulated annealing. However, the simulated annealing have the simulation cost of the quantum. So if we run on the single core CPU, simulated quantum annealing have to spend out the computing costs. So however, in the when we released the OpenJJ, so simulated quantum annealing is the position for the quantum simulation technologies. However, the OpenJJ meets the AWS Graviton. So AWS Graviton is a very powerful architecture quantum computing devices. In the AWS Graviton, we can parallelize the simulated quantum annealing. So in the parallelization technologies, simulated quantum annealing's quantum simulation cost is very decreased. So for example, the right side is the benchmark result of the simulated annealing and also simulated quantum annealing. So in the Graviton, so simulated quantum annealing can outperform the simulated annealing. That is a very awesome result, because we believe that simulated quantum annealing cannot outperform the simulated annealing because we have to pay the quantum simulation cost. However, in the Graviton, we can parallelize the quantum simulation. So these costs very decrease, so simulated quantum annealing outperform the simulated annealing. And also that recently the Graviton 3 is released, so that is more faster than the Graviton 2 in our software. So Graviton 3 1.5 times faster than Graviton 2. So if you want to use the very fast quantum simulation on the OpenJJ, so you can choose the Gravitons. Unfortunately, so if you execute this simulation, you could not start from just by the pip install, because currently OpenJJ are released for only the Intel architecture. So if you execute this calculation, you have to build by yourself. However, of course, the JijZept supports the AWS Graviton. So if you using the JijZept, you could not build on yourself. So you just call the function of the simulated annealing or simulated quantum annealing. But JijZept's backend is AWS Graviton, so you can get the Graviton's performance, but you do not have the build on yourself. So that is a very good collaboration with the AWS and also our product technological relationship.
Yeah. So same here on the AWS side too, like nice collaboration with JIJ team, right? And then this whole solution went through a technical review on our side last year, and then we ran some of the experiment with Graviton 2, now Graviton 3. So there's like a marked performance improvement here, 1.5x faster than the Graviton 2, so Graviton 3 overall. And then I believe we are also toying with the idea to test with some of the other instances which are in pipeline to see its performance. But it was a nice collaboration between the two parties.
Yeah.
I love that you put the architecture diagram in there. Thank you for that.
Yeah. So, and also we are using of course, the computing, but AWS as a computing technology, and also we also using some more fundamental infrastructure for the other services for the AWS. So,
Okay.
Yeah, we at AWS, we love architecture diagrams, so I'm pretty sure that is pretty helpful for the viewers.
Yeah, and also our architecture is very unique for the quantum stuff, is because so yeah, you know that we have a lot of developers users. So if they post the out request, so we have to manage their queue and also their jobs.
Mm-hmm.
However, in the AWS and the cloud infrastructure, so we can easily manage their queues and also their some jobs, and also our software is pretty unique stuff compared than the another SaaS-like softwares, because so we our product solve for the large scale problem. So every user's posting data is a very large scale data. So we have to consider about these how to large scale data on the cloud infrastructure, and also how to reduce the latencies. So however, yeah, you know that if you be using the like cloud service like AWS, we can easily these software stack can implement on the whole world, so we can reduce the physical distance from the customers and our software, and also we can easily manage the large scale problem using the AWS service. So yeah, so we also we always talking about how always using this diagram structure for talking about how to handle the large scale data for the customers.
Great. So I think you have spoken a lot. Hiro, what are your opinion? What are you seeing on the market with some of the driving factor where this is more applicable in your conversation with the client in Germany or elsewhere?
Actually, so when I joined the JIJ, it's March 20. It's last year, and my background is like energy markets. I had a business in the Brazil, Mexico, and Australia to invest the infrastructure, the energy utility business. So bit new for me, the quantum at the time. So what I fully understand is that it's a stakeholder is complicated in this market. For example, the researcher and the developer love a lot of the formula, but someone very hesitate, someone dislike the formula. We need to explain without any using the formula. So, and like academic and like government and business, venture capital, there are a lot of the complicated stakeholder. This is what I'm feeling about this quantum market.
Great.
What do you think, Pamina?
That's another vertical, of course, as I was saying, the optimization problem. We being in the Amazon, but we are all part of Amazon, our parent company, right? From AWS is where I belong. But we have this whole last mile package issue, right? It's common for any of the companies who deliver parcel. And this is directly connected to the some of the optimization issues when you have to go from one point to the second to third and fourth to fifth and sixth. So it is that whole routing problem, right? It also is what we call it as a vehicle routing problem, right? Mm-hmm. But the intention is how do you solve some of the biggest challenges, transport of the fuel, what you was saying, from point A to point B to point C to point D. Right. And then when you talk about, when you scale this little bit, it is easy to understand, right? That let's just pick 10 cities as a Amazon parcel delivery person. You have to, schedule. Means he gets his scheduling upfront, but the software has to schedule how do you go from point A to the B to the C to the D to the E to the F, like that, right? So what is the most optimum path? So that is what I think one of the easy way you can visualize this problem. But then extrapolate this into multi-fold with supply chain issues. If some part is originating in China, it goes through n number of points until it reaches to the customer, right? So like for the big manufacturer like Toyota, Honda, or any other OEM, right? If they're building the car, even the states, right? Like they have to assemble a lot of parts. So this is all like a optimization you need in scheduling those. So it has a direct impact on even the logistics side, supply chain.
Right.
Energy is, you guys covered energy, but you guys covered the energy from a climate and sustainability side, right? How to optimize the vehicle in a particular city, which is smart city. So under smart city, this is one aspect of, right? How do you route the traffic in that city? What is the most optimum path? But formulation of all this is tied to that whole Cubo formulation, the mathematics behind it, right? And what you was trying to tell us, like this is like a discrete side of the house, very complex problem. It is an NP hard problem.
Yeah.
So
So actually, so like we call that like energy value chain, like energy supply chain from the upstream, like export and production process, and the transport, power plant, and the storage, and the using in the like a city. The so to be like energy value chain. A lot of the mathematical optimization. And so, like Groby and CPEX is already like existing like a solution, but the quantum approach is expect to like going forward to solve this mathematical optimization. Yeah. So there are a lot of opportunity in this area.
So for anyone that's joined us late or is just joining us now, this is AWS Howdy Partner, our weekly show on Twitch where we talk to partners that are showing us some cool solutions that they've created. Right now we are with JIJ, and they're showing us their JijZept and some really cool stuff. So thank you guys. I sorry for interrupting with that plug there, but carry on.
Sure. Yeah. So I just saw when you were sharing about optimization, I see Alejandro. So Alejandro is my professor at my university too. He's from the Fujitsu, and Fujitsu have also a digital annealer, which does some of this. So he has done some work in this field around the optimization inside, and Fujitsu is known in this space too. I'm glad, like you mentioned, that they are also Japanese partner for us.
So how about the, can we ask to the audience? So it's a first time for me to join like a Twitch. So David, we ask to the audience?
Yeah, if you've got questions for the audience, feel free to ask. I'm sure that would be really cool. The audience asks you questions, but you can ask the audience questions as well. Sometimes that makes it fun and interactive. So
yeah, okay. So how about the the audience and David and the Prachi? How much you can understand the explanation of the U? So this has like a bit of like a detail of the algorithm, but something would be easy to understand. So this is my question to audience and David and Prachi today.
Yeah, so if you're asking me, well, so I did cheat a little bit because I knew that I had this show coming up. So I did read a little bit. I came in a little bit better prepared, but with that said, a lot of it is still way over my head. Quantum computing is not a subject or a topic that I am very well versed in. I know kind of just the basic fundamentals of Amazon bracket, and when you showed the architecture diagram, I was like, oh, cool, like I understand that, I get that. And then I saw graviton, and I was like, oh yeah, graviton. We love graviton, right? But yeah, that would be my answer. Like I got a little bit of some basic explanation and understanding out of it. I definitely know more than I did. So that's awesome. And thank you for that.
Yeah, thank you.
Yeah. So one question, because I know the answer, so I'm just cheating. If as a user today, the audience who's listening, Hiro, if they want to experiment with this JijZept, so can you show how to get access to? I think I know the URL.
Okay, so maybe already send the JijZept URL. So I will show how to log in I will show how to log in and also how to use the JijZept. So thank you. Sorry. And in the JijZept separates multiple layers. In that, so we defined these 6 layers. Firstly, the application layer, the modeling, the hybrid, the algorithm, and the compiler, and the solver, and the hardware. These are the bottom 3 parties of JijZept. And also that we provide a development environment we call the JijZept Playground. So I will show the playground demonstration. So in the playground, we already the JJ modeling and the hybrid algorithm architecture is already installed. And also through the playground, we can access the bottom 3 layers. Okay, so firstly, I'll show I already log in the JijZept playgrounds. In the playground, so you can see that like a Jupyter notebook. So that is a cloud environment, cloud development environment. So you don't have to prepare the install the JijZept related stuffs. Already everything is installed. And also that before my demonstration, so we have to I have to a little bit explain about some mathematical optimization and also related Kubo. So Kubo, in the beginning of this session, the Parminder's experiment describe about the Kubo. However, so a little bit complicated. So I also explain in this time. So this is a very well known the traveling salesperson problem. So traveling salesperson problem is related to for the vehicle looting problem. So if the traveling salesperson have to toward each cities or each houses. However, he want to know the more optimal. Optimal means reduce the distance of the tours. So that mathematical optimization problem written by like this. this is the called objective function. So that is this function represent the distance of the tours. And also these two equation called constraint. So constraint is the first, this constraint represents the traveling salesperson have to go to the every cities. And also this constraint represents the traveling salesperson have to in the one city in the same time. So these two constraints, however, in the quantum and quantum inspired algorithm cannot directly handle these constraints. So we have to convert to the Kubo. So for example, the left equation, the bottom equation shows the Kubo representation of the traveling salesman problem. So that means there's a constraint problem convert to as a penalty. So penalty means that so if these equation this term is to 0, so this constraint is satisfied. So and also we have to set up the parameter A. So that is the strength of the penalties. So in the conventional quantum workflow, we have to, the developer have to adjust, or developer have to find the optimal A. If we could not set up the optimal parameter A, so traveling salesman problem could not solve on the quantum or the quantum inspired technologies. So that is a little bit a difficult problem. So however, the JijZept, JijZept could compiler this feature, this compiler and the driver can automatically adjust these parameters. So developers don't have to consider about how to adjust, how to find the parameter of the Kubo. So that is a good, very good feature for the quantum developers. Okay, let me show that how to run the TSP, how to solve the TSP problem on the JijZept. Okay, firstly, I prepared some data. So this 10-point data. So we have to solving these. Oh, thank you. In the chat, so the listener posts the traveling salesman problem link. Thank you. And also that is random data for traveling salesman problem. This person have to go to the tour. Firstly, we implement the traveling salesman problem on the JijZept modeling. And JijZept modeling is very similar, looks like similar to some mathematical equation. So, but if you are familiar with the programming, a little bit, you feel that this is the little bit different from the conventional programming type, because we do not using any for statement. So in the JijZept modelings, we can use the sum function for the LaTeX. LaTeX is a very well-known mathematical equations, very well-known languages for representing the mathematical equations. So, and also the JijZept modeling has a good feature. So show the rough representation of your implementation. And also after implement the mathematical model, we set up the instance data. And also we import the JijZept. We choose, for example, this is a SQA that is run on the Graviton quantum simulation algorithm. So if we do not have the automatically parameter tunes, we have to set up the weight of the penalty. That means this parameter A. So, however, that in the JijZept, we do not set that. We do not set up the parameter A. So, okay. Run the Zept. Check. So we can Zept automatically by the processing, we can automatically analyze the solution. So this means that that is energy means that Kubo values, and also that this is the value of only the objective term, and also that this is the violation of each constraint. So you don't have to write the analysis code by yourself. And also the extract the feasible solution. Feasible means that the constraint satisfy the solutions. You check the solution, and you can find the source. That's it. So very very short. You have to write a very short code. So in the conventional workflow, you have to consider the tuning the parameters or something, for example. And also that, for example, that if you do not have the auto-parameter tuning, or for example, you have to you select by your the value of the parameter by yourself. For example, just 0.1. So yeah, so that means the violation has a finite value. That means that we could not find the feasible solution. That means that we could not find the constraint satisfied solution. So you have to, okay, so if we set the 0.1, so we could not get the feasible. So we have to, so for example, like that.
Okay. So you have to manually come up with all that combination, rerun.
Yeah. So that is a very high cost for the development. So however, if you're using the Zept, you do not consider about that. You just focus on how to create a mathematical model from the realistic problem.
Okay.
And also that if you want to the more quantum parts, so you can just rewrite this one line. So for example, choose of course you want to see the power of the conventional computer, so you can choose SA, and also you can choose bracket. But in the bracket, so we use QAOA, so we just only the small cases. So and also if you want to use a D-weight like
so
this.
for the bracket one, is there something the particular one you target, like Rigetti or INQ?
Yeah, so if you choose the bracket, you have to post on what we want the devices, like Rigetti, and we currently support Rigetti and ion keys. So from in August, we also support the Oxford quantum computing devices.
Okay. So they are all done in the realm of gate-based.
Yeah, gate-based.
Okay. Nice.
That is a very quick demonstrate. However, the JijZept can automatically manage every bowling stuff. So you can optimization algorithm just this few line. Yeah, very simple.
Right. Yeah, and then you said like you're gonna show us the JIJ playground, and under the hood, the hardware, and then the JijZept main thing. So as a user, like if I have to use this platform tomorrow, I just go via the JijZept website and create an account, and someone from your team will contact the person.
So if you want to use the full functions, you have please contact us through our website, like from here.
Okay.
And also, but you want to using from now by your local computer, you can use the JIJ modeling and also collaborate with OpenJIJ. So the JIJ modeling is free, so you can if you only use the OpenJIJ by your local PC, so every stuff is free, so you can install by pip command of the pip install. So however, if you want to use the quantum stuffs, you have to contact us from our website.
Great. So in a nutshell, if I have a local Anaconda environment, I just do the pip install and I can simulate in my PC.
Yeah.
And
exactly.
if I need to experiment with a little bit on the quantum side, I use that contact us on your side. Nice.
Yeah, exactly. Yes.
Great. So,
sorry. So, and also so OpenJIJ, I say the open source software. So we have a OpenJIJ community on Slack. So if you want to ask about the relation to technology stuff, please join the bottom of the GitHub. Join the Slack from the bottom of the GitHub pages. Sorry, I did not share the screen. Yeah, from this link.
Okay, so Slack community is there. If someone is facing an issue with install or problem formulation, someone would probably help. Great. So this is very attractive for the researcher and academia, the students, right? Sometimes, I remember without JIJ, last year we were setting all the objective function, the Lagrange multiplier, the constraints by hand. And we were running this multiple time, and then objective was to find the lowest energy state every run. So it took us a lot of round, almost all the students were running it multiple time, and we found the most optimum. There was no automatic way, the way you said, it can do the detection. Right.
Yeah. So that is bowling and so a little bit complicated stuff. For example, so if you choose 0.1 is too small, so you set up for example 10. So developer sometimes like that. So however, using the 10, so we can find the do not feasible. So we have to more choose when adjust, and also then if we can get the feasible solution, so maybe the feasible is not found. Yeah, for
So I've shared in the chat on LinkedIn, so you guys can find JIJ on LinkedIn as well.
Thanks.
Thank you.
Yeah, if we
great.
So if we choose the
while you're doing that, I just had a quick question. So you mentioned about it automatically allows you to tune parameters, and you don't have to work your way out and finding the most optimal thing here. But so that directly acts as one of the differentiators from other solutions out there. Are there any other differentiators that you would like to point out, just for our viewers, as to how this solution differs from the other things out there?
Okay, so in the other solutions, so they found that automatically tune the variational quantum parameters. However, so of course we all So sorry for complicated. So this parameter is not the variational quantum parameter. So that is a very different from these parameters. So of course, if you choose the this to the bracket, so backend run on the variational quantum algorithm. So of course, in the backend, so we automatically tune the variational quantum parameters. However, this parameter is very related to the more not quantum, related to the mathematical model. So maybe I do not. I had not seen these parameters are just the tuning features in the other platform. So yeah, so this parameter tuning is a very unique feature of our product.
Okay.
Yeah, and also I can learn that if we choose a large scale set large scale parameters, we can find a feasible solution. However, if we set up the large scale solution, the objective function will a little bit ignore, so the solver could not find the optimal solution. That is a feasible means that is a tool can connect the dot. However, that is a not good solution. So developer have to find the not too big and not too small parameter for this problem. So these parameters finding algorithm is well known as a very difficult problem, even using the great computing technologies. However, we propose good algorithm for finding these parameters. So we implement this parameter backend of the JijZept, so we can implement and also that we can provide these features.
Right.
Awesome.
But technically, if we want the detail of the algorithm, so we already talking in the more academic conference called AQC. So that presentation you can find in the YouTube. So our CTO present about the detail of the backend of the JijZept algorithm. So yeah, if you familiar with the mathematical optimization, the statistical mechanics, maybe you can understand his presentation.
Great. Yeah, and I think I just saw a lot of other problem like traveling salesman problem, like knapsack problem, multi-car, paint shop problem. Those are great set for any of the students who are still going through the studying part of the adiabatic quantum computing. Nice.
Yeah, exactly. So if you do not, if you want to learn about the adiabatic quantum computing or the optimization, so in the OpenJIJ's tutorial, so we prepare the documentation from the beginners. So like what is the Ising model, and so what is a Kubo, and also how to use the OpenJJ from the beginners. So if you want to learn, please see this OpenJJ tutorial you can find from the GitHub or I also link. So yeah, if you want to learn about the Ising model optimization technologies, you can find it from here. And also that we are the Japan-based startup, so we also prepare the Japanese document. So if you are the Japanese, you can read the Japanese document also.
Yeah. So I just saw if you scroll down below the machine learning, you guys are solving some of the quantum machine learning too?
Yeah. So we also a lot of machine learning stuff is, for example, in the quantum machine learning is using the inside of the quantum are using the inside of the machine learning. For example, the neural network represent on the quantum circuit. So of course we support these stuff and also we also support the quantum are using of the outside of the machine learning. For example, so we set up the multiple model, and also we solve how to ensemble multiple models by the quantum technologies. So we support two technical parts. So yeah, if you want to see about quantum machine learning, you can also see from these documentation.
Great. That was a learning for me. At least I learned this. I thought like you guys just do the optimization, but it's good to know this, the QBoost, and then the PyQbo I'm seeing on your screen right now. Great. Nice. I hear a beautiful sound in the background. It must be your daughter or son.
He's got the baby.
Sorry, so my baby as a
no, that's fine. Hi, baby.
So currently she eating the breakfast. Okay. Yeah, so she currently she didn't like it. So breakfast.
I know.
Crying, yeah. Right, yeah.
I know, because I was saying to Hiro, we wanted another time, right? Like you said, like this 2 to 4 is the time kind of like we get from AWS for partner facing event, right? So we could not change that. But, thanks again. Like you guys doing this early morning, your time. It's tough time. But
yeah, no worries. I've been there before. I almost always have my grown-up babies running around. They don't seem to get any quieter. So
great. So what else we don't know, which you think is useful for the audience to hear?
Yeah. So audience. Yeah. So. Yeah, a little bit. Also, the Nakata says a little bit wonder about that. So I talking a lot of the very technical and the science part. Mm-hmm. So yeah, if the listener want to know more detailed, please. I want to take a question, and also after this session, you can also ask up through the Slack or also my Twitter. Yeah. See.
And I'm looking at the multi-car paint shop problem. So seeing on JijZept, there's a lot of cool stuff that I'm looking at here. So it wasn't just like the traveling salesman you showed us, but there's a number of things that I'm seeing here along with like some TVs and stuff. So this is I'm going to drop that link in the chat, but this is really cool stuff. I'm going to come back and play with this later for sure.
Yeah, thank you.
Cool.
Yeah, and also so in the optimization is difficult for the understand because in the quantum computing industries we have a lot of physicists, so they love the quantum stuff. So many applications into the quantum chemistry. So because the quantum physicists very familiar with the quantum. So if you are physics students, so you can I believe you can easily understand the quantum simulation application. However, in the optimization area, so a little bit complicated because the optimization is a little bit different from the mathematics is a little bit different from the quantum. So if you want to create the optimization application in the quantum, so you have to understand both mathematics. So yeah, so the optimization player is a little bit small than another chemical simulation. So we currently spend time for the education or the create the material stuff is for the learn about the both mathematics. So yeah, if you interest mathematics optimization and also the quantum, so please learn from our website, and also we hope that you joined about these research and also the developing areas.
Great. Yeah, I hope audience really probably will go after this call and start experimenting with this software, right? Like, because I remember like I had to do all of that by hand in a sense, like very rudimentary manual way. I learned something today, the automatic thing. I would have been able to do my assignment quickly rather than spending hours to find the most optimal parameters. Last year, yeah.
And I just dropped our survey link in the chat. So for anyone, please let us know. One of the questions is, did you learn something today? So hopefully we all did. But we like our surveys, so I dropped that in the chat. Go ahead and take our survey if you would, please.
Yeah, you can run there.
Cool.
So is there any other ways that we can connect with you guys, you, Hiro, or JIJ? We've got you on LinkedIn. Is there anything else that you want to put out there?
Okay.
So for me, LinkedIn is better. Yeah, please contact me on the LinkedIn if you want.
Yeah. So yeah.
Great.
Yeah, great. Yes, and also that. Yeah, I'm on the Twitter. So, of course, yeah, I can. I also using the LinkedIn. However, I'm on the Twitter. So that. So in the quantum physics out. So yeah, they're using the Twitter. So yeah, I'm also using Twitter.
Great.
Awesome.
Nice. So then that's it, right, Daniel? I think we covered most of the stuff.
Yep. So I just threw your Twitter in there on the chat there, so everyone can see that.
Great.
Cool. Well, yeah. Thank you so much for joining us, guys. If there's nothing else, is there anything else you wanted to share?
Thank you.
Nothing from my side.
Okay. So a little bit. So currently we are we find a partnership with collaboration with the JijZept. So if you are the industry users, so please contact us from this email. And also that we find software engineer and also the researchers. Of course, if you are familiar with AWS, please join us our backend teams. So we are currently creating more stable infrastructure on the AWS for create the JijZept. And also that currently we find internship student. So if you, but don't worry about if you do not familiar with the optimization or the quantum. So, but you have to you can write the Python. So we are prepared a course from the learning and also the create some the tutorial. For example, Daniel shared this link. So the half of the tutorial is created by the internship students. So currently we prepared more out of use cases on this website. So if you are students, please help us to create the material for the tutorials of the JijZept. So yeah.
That sounds really cool, like a fun opportunity for people to get involved. I like that.
Yeah, I know. Definitely, I would have loved when I was a student. So anything to get involved with an open source technology where you can ask questions or you can experiment with, or even intern, I think that's always good to have on your resume. So yeah, that's definitely a cool opportunity.
Great, thank you. And also, chat, thank you. The comment. Yeah, please submit the internship.
I know. Great.
Awesome. Well, thank you so much for joining us today, guys. All the viewers, thank you for coming and watching. Really cool, informative stuff that I'm going to definitely go look into a lot more. Quantum is coming around on these shows a lot more often. We've had quite a few of them, and just seems like it's something that's really going to pick up more steam. And so I'm really interested in it. I'm just going to learn more as much as I can. So yeah, I appreciate you all joining us and hope you learned something. Prachi, Parminder, any other thoughts from you?
No, I think I just want to thank JijZept team. Right, it's not easy
Thank
to
you.
Thank you.
do this at 6 o'clock when you're waking up, right? And then you're speaking. But unfortunately, we had this time, locked. We could not change that time. But fortunately, the hard work here and then explaining the product to our audience, they would start experimenting with this, as I was saying earlier, right? I wish I could have this last year. But nonetheless, the students who are still in the college or the industry users, right, can benefit greatly from this. So with that, I think we should wrap up. And I will let you guys go because still I think morning work and course and your baby probably needed attention. So thanks again.
Yeah, thank you again, guys, for waking up. And yeah, definitely was an interesting show and a very detailed demo, I would say. So thank you for preparing that.
Thank you also. Thank you also for this opportunity.
Yep. All right. Thank you. Thank you, Hiro. Viewers, survey link is in the chat. Please go ahead and take that survey for us. And be sure to tune in next week for Howdy Partner, same time, 2 o'clock Pacific time. We're going to have Palumi on. So excited to have them on. Should be an exciting show. So thanks for joining us. Take care, everyone.
Thank you.
Bye-bye.
Bye.
Bye.